In a specific year, 53.7% of men in the United States were married, and 50.3% of women were married. Random samples of 300 men and 300 women found that 178 men and 139 women were married, not necessarily to each other. At the 0.05 level of significance, can it be concluded that the proportion of men who were married is greater than the proportion of women who were married? So our first step here is to determine our H0 and H1. And we're dealing with proportions here because it says, can it be concluded that the proportion of men is greater than the proportion of women? So in this case, because they give us men first, I'm going to make men P1 and women P2. Okay, so we have P1 equals P2 and P1 and P2. So they want to know, is the proportion of men greater than the proportion of women? So that's our claim. Now let's draw a distribution. Or let's compute our information first. Let's figure out what we're given. So, P1, they're saying in a specific year, 53.7% of men, so 53.7% is a decimal, is 0.537. And then they say, and 50.3% of women, so P2 is equal to 0.503. Then it says random samples of 300 men and 300 women. So here, P bar 1 is equal to x1 over n1, which is equal to 300 men. And the same thing over here, we have P hat 2 is equal to x2 over n2, 300, because they have the same sample size. Then it says 178 men and 139 women were married. So we have 178 men for x bar, for x1, not x bar, and 139 for women. So when we plug that in a calculator, we get 0.593. And when we plug in P hat 2, we get 0.463. And now remember, Q hat is 1 minus P hat. So 1 minus P hat is equal to 0.537. And same thing with Q hat 1. 1 minus P hat 1, which is 0.407. And then they tell us at the 0.05 of significance. So we have alpha equals 0.05. So now let's find our critical value. Well, actually, to do that, we have to draw our distribution. And we know it's a right tail test because of h sub 1. Now let's compute our critical value with a one tail test. Alpha equals 0.05. So alpha equals 0.05, one tail test, all the way to the bottom, because we're dealing with z here, not t. So we get 1.645. It's positive, because it is on the right side. 1.645. Now let's compute our test point. So as you can see, I've already written out the formula. And now let's plug in our numbers here. p hat 1 is 0.593 minus 0.463 minus, and this is just 0, all over the square root. Oh, we have to compute p bar and q bar first. P bar is x1 plus x2 over n1 plus n2. And we have 178 plus 139 over 300 plus 300, which equals 317 over 600. When you plug that in your calculator, you get 0.528. And just like p hat and q hat, q bar is equal to 1 minus p bar, which gives us 0.472. Okay, now that we have those, let's finish plugging in here. Okay. And square root p bar times q bar, which is 0.528 times 0.472 times 1 over 300 plus 1 over 300. Let's go plug that into our calculator. So we have 0.593 minus 0.463 divided by square root of 0.528 times 0.472 times parentheses 1 over 300 plus 1 over 300 is 2 over 300. So I'm just going to put 2 divided by 300. And we get our test value to be 3.19. So now let's go to our distribution. And we see 3.19 is way over here. Therefore, because it is in the shaded region, we reject.